So let's give you a brief overview of how we generate the data that goes into the data sheets, because it's quite a complete process. And what we want to make sure is that you understand that for us, the data sheets are not just the best possible numbers that you can get, but actually representative of the parts or of the results that you actually obtain from the prints. So first, whenever we start with characterizing new material, we have this first phase where we're just looking at bulk density. So basically what we do is we print a reasonably small sized sample to the tune of maybe 6 by 2 by 2 centimeters. And we print this sample geometry with about 18 different settings. And we vary the energy input, the layer height, laser power, etc. And the goal is we use these samples to do a hardness measurement. So we see as printed, what's the hardness like? And also as printed, what's the density like? And there we're looking at bulk density. So we're doing a CT scan. So basically we print the samples, we extract two little samples that are more friendly to CT scanning. We look at all of these 18 samples in different print settings. And we're basically looking, okay, where in this range do we even have the chance of getting the best material properties? So, and sometimes we have to repeat this phase because we don't find any satisfying results. Sometimes we find a lot of satisfying results that could work. And then basically we sample the best 3 results from this phase. And we go over to the second phase. In the second phase, we're actually building a much larger sample to the tune of maybe 12 by 6 by 3 centimeters is the one that's pictured up here. And we actually use this to do tensile testing primarily. So from these samples, we're actually getting tensile results. We're looking at density in the microscale. So just looking at the CT scan is basically not enough for getting good density data, because this only shows you bulks that are visible, or like defects that are visible to the CT scan. In this case, we're also doing micrography. So we're looking at much smaller details, which could be distributed more or less homogeneously throughout the part, which might be gas bubbles or other unwanted alloys that might be forming, or phases. So we're doing, pretty large blocks. We're doing a fairly large number of tensile tests to get representative results. We do tensile testing usually in the X and XY and the XZ plane. So we check for both directions to make sure we see what our anisotropy is like. And lastly, also in this phase, we apply heat treatment. So in some materials, as we'll see, we actually need to apply heat treatment to make sure that we get best material properties. And this is what we're applying in this phase. And also we're obviously looking at the hardness after the heat treatment. And lastly, once we've established these properties on the second phase, we can start making a data sheet. But this doesn't mean we know every single thing that there is to know about this material. So basically then we go to the third phase, where we take the best results or the best sample block that we've achieved in the second phase, and we're going in detail. And in going in detail here means, first of all, we validate that our initial results are correct. So for example, we would repeat a tensile run. But more importantly, we'd be looking at things like fatigue testing, if it's an alloy that would be typically used in high fatigue areas. We look at things like chemical analysis, if it's a cladding, like if it's an alloy that's prone for cladding applications. That's where we're looking at dilution. And we might be looking at a various array of different things. For example, we might also be looking at the oxygen content of the sample in the case of titanium, because it's a very critical value. But basically what I want you to go away with from this training is, okay, we do this first phase, then we're just trying to figure out, hey, what's the process window? Can we make a dense part? And dense meaning we don't see any voids on the CT scan. Then we do the properties. So with these dense parameters, we're going to check the first basic properties. And then from there, we're going to go into an in-depth study where we're actually looking at what's really important for this specific material.